We have a presentation on developing riparian conservation networks to develop ecological resilience, and our speaker is Alexander Fremier, who is an assistant professor at the School of Environment in Washington State University, and he his research is focused on geomorphic and ecological processes and how they interact to transform a riparian and riverine ecosystem. Alexander?
Oh, that's what I did immediately.
Did it go out?
Yeah, good.
You're okay? And you know the middle is a red thing if you want a laser. Okay.
Thanks. Hi, everybody. Thanks. Just full disclosure, scientifically speaking, my three favorite words are resilience, restoration, and riparian. So this meeting has been really informative. It's been fun from the diversity of ideas standpoint. What my co-authors and I have been thinking about is based on two observations. One, that some of the ecological issues of today are larger in spatial scale, and one of those issues being habitat connectivity. So the cliff notes for this talk is essentially thinking about the observation of how do we build habitat connectivity under increasingly changing climates, as well as a habitat a landscape that is increasingly fragmented. And the second observation is that while we do a lot of stream restoration, especially in the West, but all over the globe, particularly in the United States. So thinking about biological conservation in the United States, backing up all the way back to the early thinkers, at least in the modern era, in the first century of conservation is really the hallmark that came out of the first century of conservation here in the US, are protected areas. Protecting areas of natural wonder, thinking a little less ecologically how we think about the world today and how we think of conservation, much more of a preservation ethic, and thinking about let's preserve these particular areas for generations to see. And what we see on the landscape is a lot of high elevation areas that are protected, and they tend to be natural wonders, more like geological wonders, of Yellowstone and Yosemite being the prime examples of that. And we're thinking less about these large-scale ecological processes that we're faced today. So the conversation now in Washington, as well as other places around the globe, but particularly in Washington related to protected areas, is what does the second era, the second century of conservation look like in the United States? And I don't think I need to tell any of you, or you're not going to be surprised, that probably the second century of conservation here is really going to be forcing us to think about climate change and forcing us to think about habitat fragmentation. That climate change, the habitat underneath our feet are moving, and habitat fragmentation, if it is going to move, how is it going to get to the places that it physiologically needs, that it desires to go to? And so the question here is, if that's the motivation and if that's going to be what we need to focus on, how do we actually do that? How do we build ecological resilience to these larger spatial scale problems? So in some sense, the protected areas are a static solution to a dynamic problem. The dynamic problem meaning the ecological patterns that we really understand today are much larger in spatial scale, i.e. if you protect an area and it increases in temperature or it starts to dry out, that protected area is no longer representing what you thought it did when you first protected it. But that's the legacy that we're left with, and so now that protected area system, I'm thinking about national parks, but also thinking about a lot of the protected areas that we have now, and I'll talk more in the definition of that. Really, that's the de facto system, conservation system that we have on the landscape. And I say de facto meaning that it's really an administrative system, and it's not yet fully managed as an ecological network. But it's more separate pieces across a landscape, and there's administrative connections between them. And No surprise here for people living in the West. A lot of the protected areas, a lot of the public land is out in the West, as you can see from that map. And that leaves kind of, that's the legacy of conservation past. Great, so in zooming back a little bit more, if we're thinking about non-stationary conditions and thinking about conservation, we should be thinking about resilience. And there's a whole body of literature in thinking about resilience and how do we make systems, how do we build systems to have the capacity to withstand some sort of perturbation. And that perturbation could be a slow change or it could be that pulse change, some sort of large, quick perturbation. And that could be by resisting that change, it could be recovering from that change, or it could be an entire transformation. And so the question that we're really interested in is how do we build the capacity for these systems to deal with that change? Going back even more and looking into the literature, there's a nice paper that came out in 2012 and reviewed the literature from a social ecological context and started asking, well, what are the emergent properties of the way people are thinking about resilience? And let's not just take it from a natural scientist point of view or a social scientist point of view, but let's try to merge them. I don't think I need to convince anybody here that these are definitely linked systems, so our scientific understanding and our communication of it should link these systems in very specific ways. And what they did is they broke it down into these 7 principles in very kind of active voice, described them. They split it up into the top 3, which are much more of the natural science types of approach. So managing diversity and functional redundancy, thinking about habitat connectivity, or maybe modularity, the opposite, so not all connectivity is good or desirable. Thinking about those slow variables. What are the slow variables that are at work in your system, and what are the feedbacks that are changing with those slow variables? And then that latter part, which I'm not going to cover too much, but really is thinking about the governance of the system, of that natural system. We heard some really nice examples of learning and experimentation today, that experimenting with the landscape, seeing it, how it responds, learning from that in this adaptive management type of approach. Polycentricity, I never say that right, is thinking about governance, and do we have overlapping layers of governance, so if one piece fails, maybe the other piece will catch it. And really thinking about these as complex adaptive systems, that they're constantly changing, and we need to envision these systems as complex and as adaptive and as ever-changing. So like I alluded to earlier, what I wanted to focus on here is managing connectivity and modularity, or the opposite maybe of connectivity, and how do we do that? If we are trying to build connectivity, if we've made the observation that a small postage stamp protected area is not enough, how do we build connectivity between these protected areas, or the areas that have some sort of conservation value or some sort of conservation protection? So there's generally, you go into the literature, and there's generally 2 types of approaches for building connectivity back onto the landscape. Usually starts with some sort of GIS analysis in a spatially explicit format, and most people take a species-specific approach, or they take a habitat feature type of approach. Species-specific corridors, select a species that's maybe charismatic, or something that you would call an umbrella species, that if you protect its habitat, then you protect all the species underneath it. And so if we protect that species habitat, then we're going to have more species using those corridors. Those projects tend to be smaller in spatial scale and very research intensive. What are these habitat requirements? What is the least cost path to get this species, sort of set of species, from point A to point B, and C, D, and E, and all of the above? They tend to be limited in implementation, actually going from these research intensive approaches and going into the implementation phase tends to be there's not a lot of action on it on the ground, predominantly because they're incredibly costly. Trying to do this at the small scale, trying to scale that up to a really large scale is probably financially not feasible. And then On the opposite side of it, there's groups that are working on thinking about mountain ranges or ridge lines as the connective tissue for connecting large, very large area, continental scale areas of continental scale, across continental scales. So it's mountains are a common landscape feature. It's really thinking about large scales like connecting the Yukon to the Yucatan, looking at where the protected areas, they tend to be in mountain ranges or higher elevation areas, and linking those. Very large scale, opposed to the opposite, which is potentially a smaller spatial scale. And the question is, are these applicable at a smaller spatial scale? And other questions arise like, well, what about non-mountainous areas? How do we build connectivity across those? So the one we're kind of playing with, and I realize it says river, and I meant riparian, but riparian connectivity network. What we wanted to add to this conversation is looking at a different habitat feature and saying, well, we're doing an incredible amount of restoration and a lot of focus in riparian and river systems. How about using those areas as the connectivity tissue between the protected areas? And we came from it from 2 points of view. Half of the co-authors are ecologists or conservation biologists. The other half are legal scholars. We brought the legal scholars in later in the game because if we deal with a riparian area or if we deal with water, especially in the West, you need a lawyer or at least a legal scholar by your side. So the ecological justification here that we're putting forward, and this is really kind of a gauntlet paper that we wanted to put out there, put the idea out there, because there are issues with it that I hope the questions will bring out. And that is riparian areas for most parts of the globe are ubiquitous. And they're ubiquitous across most landscapes. They're linear features that connect large areas of land. They're highly productive. They have high diversity. We understand that not all species would use riparian areas to move. I'm thinking about terrestrial species, not aquatic species. But certainly there is evidence out there from smaller scale scientific studies that suggests that if with no other options, a lot of species will use riparian areas to connect. And that ecological classification or that ecological justification, if left there, it would probably stay in academic journals and not emerge and actually get applied. So we wanted to bring in more of, from the governance perspective, would this be a good idea? And then how would we fuse this idea and actually get it out onto the landscape? And so the policy justification, it became really clear. We care about clean water and we care about the species that are near water. We like, for aesthetic reasons, to look down at a river and have it look beautiful. Whether it's the species that we think should be there or not, for most of the public, they want to see clean river systems. Clean Water Act, the Endangered Species Act, there's a whole bunch of policies out there to help us protect riparian areas and rivers. And that's because we genuinely care for the hydrological ecosystem services, recreation, clean water, biodiversity. And from a policy perspective, in terms of scalability, riparian areas, although maybe in a small spatial scale they're difficult to define, at a global scale or at least at a continental scale, they're relatively easy to define if you compare them to these small scale habitat-based or species-based definitions, that you could imagine a policymaker in Washington saying, well, where are the riparian areas? And you could easily give them, you could immediately give them a map of the stream network and say, well, here's the start. Here's maybe a backbone. Let's work from here. And so in terms of the justification, we think that there's ecological and policy scalability, that we can go maybe from the small scale to the large scale to start building ridges and riparian areas in these smaller scale species-specific approaches to start building a connectivity network. So what we did, we collected some data. We went out there and looked at the protected area database. These are large spatial databases that are publicly available. The protected area databases is all the protected areas in the United States. And what it includes is the level of protection, level of conservation protection. And I'll tell you about the details in that. NHG Plus is the National Hydrography Data Set. It's the blue line, essentially. All the stream network across the US. NSED is the National Conservation Easement Database. And then FEMA is the Federal Emergency Management. I don't know the acronym, but we all know 100-year floodplain maps. So we looked at those and asked 4 basic questions. How many of the existed protected areas that we have out there now could be connected by the stream network? What's the percentage of those riparian corridors or the stream network that are in protected areas, that are in protection? And then what is the spatial configuration of those protected areas or protected stream network? And then finally, what do the conservation easements look like? And are they spatially associated with streams? So I'm going to skip all over the methods and get right to the results. And we were surprised by a few of these. We weren't surprised by this 95%, but if you were to look at 95% of the protected areas now could be connected by through the stream network. That's a much, the details in there are complicated, so I won't talk about them right now, but we could talk about them afterwards. What we were really surprised by was that 24%, and it's 24% of the stream network, this is a linear unit, is actually in protection. If you compare that to the terrestrial by area measurement, so there's an issue there, it's only 10%. And so we actually, this is just evidence, nice, clear evidence that yes, all these decisions that we're making out on the landscape, we actually are biased towards our protection towards rivers and riparian areas. Not a huge surprise, but a nice result to write down, especially writing it down in a paper, to say, yeah, we feel like there is a societal motivation for protecting areas. Now let's take a look at it, a deeper look at it, and look at that spatial configuration. What I want to point out here is of that 24%, 73% is in this gap status 3 land, and what that is working lands. So timberlands, BLM land that actually are working but have administrative protection of riparian areas, riparian buffers on national forest land. And so even though it's not protected as a whole, the riparian area has administrative protection. Now, is it restored? Is it actually healthy? That's a different question. But in terms of, from a policy perspective, it is protected. So here, just to make sure I'm being clear, here are the definitions of protection of what we used. One is your wilderness areas that don't allow for the conversion of natural land cover and allow disturbance. Getting all the way down to 3, this allows no conversion of natural land cover, but the disturbance can be removed or not allowed. And then 3 are those working lands that have extractive uses. And then 4 is that kind of everything else that doesn't have any long-term conservation protection. So what we did, what is this, to answer the question or to look at the question of where is our protection? Instead of looking at elevation with a stream, it doesn't really work all that well. So we put it by stream order. So headwater streams, mid-sized streams, and your largest streams down here. And you can see overall we have in the headwaters 24% protection, and then it decreases with the increasing river size. Now, since I am at Utah State, I should give a shout out to the geomorphologists because there's a lot of them here. 24% of protection in headwater streams is very encouraging if you're considering that a lot of the ecosystem services that we get from rivers are actually generated locally, but then transferred downstream, water quality, sediment, etc. And so having higher protection in the watershed from an ecosystem services point of view is a good thing, as well as this is also, we tend to protect higher elevation ecosystems more. But responding to earlier papers that we tend to protect rock and ice, this is a nice observation that some of the later protection is now being moved towards rivers and riparian areas. But especially in this group, this is thinking mostly about public areas, so this would be a public land solution, and maybe on private lands, there's also some other issues that are going on. So here is just a map, a heat map, but kind of the heat in the other direction, where we took the small watersheds and looked at the percentage of the stream network that is protected. It's no surprise that the West has a lot of the blue areas where we have more of the protection. But there's still a lot of issues. If you're going to take a public land solution, or if you're trying to build connectivity across the United States or maybe smaller regions, you're going to have a problem in the Midwest, and certainly you're going to have other issues in the East Coast. So what about private land? Is there a private land solution out there? So what we did is we looked at conservation easements, and this is a conservation easement database. The motivation for these conservation easements is highly variable. The amount of protection is highly variable. So we're not saying that this actually has protection, thanks. But certainly there's a lot of them out there. This map is a little bit confusing because these conservation easements are very small. They just appear really large just so I can actually show them. But I'm going to zoom in and you can start to see it. The question here is, do we have more conservation easements in floodplains or riparian areas? And you can start to see if you zoom in right here, purely as an example, if we zoom into the lower Mississippi, certainly we start to see more of them inside of the Mississippi floodplain. Not to say that this is protection, but it's saying that it is an emergent property of the current governance system that we are protecting riparian areas more than upland areas. We did some other analysis to show this on smaller streams to see if it was more or less higher or lower protection in different areas, but this is just, I'm using this just as an example. And so really the point we're trying to make here is that the current policies, all of them, not just one in particular, and our restoration efforts are really nice, is a really clear evidence that we as a society have concern for hydrological services, and that's motivated both by clean water but also species conservation. And that the riparian actions they have aquatic implications, but they also have upland implications. And then tying that to the larger scale, if the large-scale ecological conservation concern is going to be how do we move species around this increasingly fragmented landscape, maybe we can use riparian areas not just for their conservation value, their species conservation value, but also for all those things we care about in riparian areas, i.e. the motivation is not necessarily for conservation, it's for clean water, and we can couple those things. And that really the approach that we tried to take is we recognize there might be an optimal physical solution, but really it has to be, from a policy perspective, it has to be implementable. And so that's what we're pushing on that thinking. And we think this riparian connectivity network is that type of approach where we could get different agencies and groups to the table to try to solve this large-scale ecological problem. And I'll just kind of show you some of the ideas, and I learned a lot about this, and this is one of those moments where your teaching actually influences your research, which is fun. Trying to put together a list of a lot of the policies that are out there right now and how they protect riparian areas. The Clean Water Act, no surprise here, really for identifying areas that need rehabilitation, but also there's monetary incentives to do restoration on those lands. FEMA, maybe it's not, it's taken some hits recently, but certainly there is a coordinated policy already in place that we can build upon to maybe make this system work. The Farm Bill, even though it got gutted, really the Conservation Reserve Program already tries to do this by paying people to take land out of production because of sediment issues or a range of different issues. But the idea here is really that it doesn't require, something like this would not require new legislation. I think, again, it's no surprise that if we are going to put forth, hey, here's some new legislation, that this is no climate right now for enacting some sort of large-scale federal policy. And then the list goes on of these from different groups and from different focal areas of how to build conservation and how to build corridors really from different agencies and different ways of doing it, incentivizing. One example of that is really just the coordination that we need to do this. We're already doing restoration out on the landscape. The funding sources are there, whether we like them, whether it's most efficient, that's not the question, but really coordinating those efforts. And here with the LCCs, it's a nice effort to say, let's start to coordinate all the agencies who are doing this type of work, get them to the table so we can coordinate it. Thinking about, okay, we're doing restoration, can we actually put those restorations, add to that complex math of which restoration we're doing in which location, can we actually add to it a spatial context of, if we're going to do the restoration here, can it also build connectivity across this important area? So I will stop there and just put that slide up there. Thanks. Oh, so I do have time for questions. And before I say that, there are a lot of issues with this, and I hope you will pick at me for those issues. Some people, especially graduate students, like to find holes.
Questions?
What spatial scale are your network models? Are you using information like Landfire?
No, it's just an overlay between the stream network, just the blue line, and the protected area. It's a very simple analysis. We're doing some other work related. Oops, sorry, skip through this. Looking at the stream network as a traffic, it's a GIS tool. Yeah, I can't remember the name of the tool, but anyway, it looks at if you are trying to go from point A to point B or point A to one protected area to all other protected areas through the stream network, where is most of the traffic? So there's no physical, it's spatially explicit, but I'm not modeling species movement at all.
Question back there.
Yeah. Yeah, so how to move forward in the policy realm with such an idea. I've been in contact with the American Institute of Biological Sciences, and so they're the ones that produced Bioscience, the journal, and their whole goal is to try to get more science into the policy domain, into the policy world. And so they've made, it's been really nice to interact with them because they have the knowledge of when and where this might be important. And so one of the things that they proposed is to have a party in Washington that you give a small presentation and then you have like a beer session to talk about this idea with the legislative aides or whoever will show up. And that's specifically kind of targeting the people who would be interested in this type of thing. And so from like the pinhead scientist in the working on the computer, that's really scary, but it's also that's the interface that has pushed me into. It's been fun to work with the lawyers because I would have no idea where to start.